Okay. Okay, class. So let's we continue with the X-ray and we go for CT scan. Okay, so recall back what you learned yesterday. So we talked about band theory, then we went to X-ray. Okay, how X-ray produced tumor when a high-speed electron was bombarded on a metal surface. The kinetic energy of the electron converted to heat and X-ray. Okay, the production of X-ray. Need to explain this graph. Altogether, maybe 7 marks. Explain why the graph, why the X-ray comes out from the tube is like this. Okay, different intensities, different range of wavelength, and some peak value. Okay, so the range 3 marks. What's the first 3 marks explanation? First, charged particle accelerates, give off EM radiation. Second, the electron and collide makes a series of collision, therefore series of acceleration, therefore a range of wavelength is produced. Okay. Why the cutoff? The minimum wavelength happens when the electron make a head-on collision. Okay, make a head-on collision. What happened? All the kinetic energy is changed to one single photon, which has the lowest wavelength. Okay, so you see head-on collision. They blame to the head-on collision. They all are theory, not proven, but they say it's what happening inside. And then after that, the peak is what? The peak electron go and collide with the initial electron. What happened to the initial electron? Excited and de-excitation, emission spectrum, which is responsible for the peak value. Okay. Then 1 year they asked how this graph going to change. Let's say this the graph happens for 20 kilovolt. How this graph going to change if the voltage applied is 50 kilovolt and the voltage increase? How the graph going to change? How the shape going to change? Yeah. So when the voltage is raised, the electron is more energetic. The electron has higher kinetic energy. Okay, it has higher kinetic energy. Electron last time electron is quite slow, now got high kinetic energy. You see the metal is going to hit. Now last time we collide 5 and it stops. Now because it has very high kinetic energy, so you're going to collide 5 times, or you're going to collide more particles before come to stop. More, right? You stop more because you need to collide more because there's lots of kinetic energy. Therefore, what happened? The area of the graph represents the number of photon comes out. So now the area going to increase, and you give high voltage, and the voltage increase, the area going to increase. Okay, so the area going to be big area. The short wavelength going to be even shorter or longer? The minimum wavelength get shorter or longer? Get even shorter, right? Because EV equals to HCO lambda. Big voltage going to have a big kinetic energy, so lambda going to stop even smaller. So it's going to be shorter, big area. The peak going to happen the same position or different position? Going to happen in the same position. Okay, the peak going to happen in the same position. Come down, the peak will be the same position. Sorry, okay. Now the graph you have to draw for big voltage. Maybe for 50 kilovolt, it's maybe 20 kilovolt. Okay. So in your mind, you must have a reason. Why big area? Because more photons produced like last time, compared to last time, because the electron has more kinetic energy. Why the wavelength, the short wavelength gets shorter? Because yes, the wavelength is inversely proportional to the voltage applied. So the wavelength gets shorter. Okay. Then why the peak happens at the same location? What's the reason? The peak is a characteristic of the metal, the energy level in the atom, the electron energy level in the atom. The same atom it collides with. So the electron energy level going to be the same one. Okay. How do you change this peak happens in a different location? What do you change to have the peak at a different location? The metal change to a different metal. Don't use tungsten, maybe use other type of metal. Then other type of metal have a different atom, the different atom have a different electron energy levels. Then the peak will change. Okay, as long as the same tungsten used, the peak will be the same. 7 marks, explaining and how to sketch the graph. Okay. Okay, I think this graph tells that. This graph tells that what happened. The area get big, the wavelength get shorter, but here they never show the peak. Well, the peak have to be the same location. Okay, so today let's talk about the image production in hospital. How are they going to use this X-ray? Okay, first, X-ray has something called intensity. X-ray has its own intensity. How intense the X-ray comes out? The X-ray beam is determined by the rate of arrival of electron at the metal target. The tube current determines the intensity. The tube current is controlled by a heater. Yeah, the tube current. You know the filament just now. The filament at where the electron is produced. Okay, you want the intensity to be raised. That means the amount of electron produced must be raised. More electron must be produced from the heater. So the tube current, the current in the heater determines how much of electron comes out. More electron comes out, more electron going to hit the target, more photon will comes out. X-ray is more intense. Okay, more intense. So intensity determined by the tube current. Not even once they ask in exam about tube current. Okay, so far. Okay, this tube current is controlled by the heater current. The greater the heater current, the hotter the filament, and greater rate of emission of thermoelectron happens, more electron comes out. Greater rate, rate means the number of electron comes out per second is higher, so more intense is the X-ray. Okay, so just highlighted points only. Next is hardness. Okay, what is meant by hardness? Another word for hardness, doctors talk about hardness, but what we talk is actually a penetrating power. How penetrative is the X-ray? Okay, how dangerous is the X-ray? Hardness. More harder the X-ray for the doctors or physicists is actually more penetrative the X-ray. Yeah. So hardness means how penetrative or penetration power is hardness. Okay. The hardness, how do you make the X-ray comes out from the tube more harder, more penetrative? Short wavelength or more longer wavelength to be used? Short wavelength. We want the X-ray tube comes out with lots of short wavelengths. How to get short wavelengths? Control the voltage. Yes, voltage. Just only way is controlling the voltage. Increase the voltage between the anode and cathode. High voltage, the short wavelength get greater. The graph get be more shorter, right? Okay, graph. See the wavelength get shorter. But this is useful. The one shorter one is useful. Okay, we still cannot like ignore there is existence of short wavelength too at the same time. But the one contributing to the imaging is the long wavelength does not contribute to the image. The short wavelength is the one most useful. But you want to go for, like, as I say, radiotherapy, you have to use a high voltage. So more short wavelength will come out, so more penetrating. So how do you increase hardness? Increase the voltage. Increase voltage, more short wavelength produce, so more harder, okay, penetrating to the bone. Yeah. So more penetrating X-ray have a higher proton energies, the larger X-rating potential is required. Okay. Referring to the spectrum X-ray produces, it can see longer wavelength. Soft X-ray also produced. So X-ray photons are low energy that they would not be able to pass through the patient. Yes, waste for us. Okay, short wavelength. So they would contribute to the total radiation dose. Yes, it's not only not help us to contribute to the imaging, but they give trouble, give more dose to your body, more radiation dose to your body without any useful purpose, no useful purpose. So they use an aluminium filter to filter out low wavelength at the tube itself. At the top tube itself, and the X-ray comes out, there will be an aluminium filter to filter the low wavelength. The one more penetrative will pass through the filter. aluminium sheet. So how do you remove the longer wavelength which is not contribute to the imaging? Use the aluminium filter at the opening of the X-ray tube. Okay, X-ray tube, when it comes out, there is aluminium filter to filter the long wavelength X-rays. Okay, so one question about calculation is find the shortest wavelength. What is the shortest wavelength ever produced by a in an X-ray tube? So you see this question, look at the solution. So exciting potential between the cathode and anode for X-ray is 30 kilovolt. They use 30 kilovolt. Given the Planck constant is this much, the charge on the electron is this much, and the speed of light is okay. Calculate the minimum wavelength. The minimum wavelength means we assume the electron makes a head-on collision. One collision happens. So all the EV energy converted to one single photon. You see your lambda. So you get your lambda, the minimum wavelength. Cutting. In the graph, the cutting wavelength. Okay. Yeah, the intensity versus the wavelength. So you get the shortest wavelength. Okay, so HC, go to the front page, get the value. Planck constant in the front page. Speed of light also in the front page. Yeah, elementary charge also you have to refer to the front page. Okay. Okay, I think shouldn't be a problem. Go to the next slide. Okay, X-ray imaging. Okay, so your X-rays. Let's say you go and buy a TV. You check. You want the image to be very clear. Two things to be considered: how much of contrast it has, and how good in the sharp. How sharp is the image? How sharp is the image? How contrast the image it produces? How big is the contrast? That's the two factors lah. That coloring, how colorful it is. Okay, so same thing goes for X-ray. The X-ray imaging, when the doctor want to see, you want to have a very good quality image. So they think two things: contrast and sharpness. How sharp the image it is, how contrast it is. If contrast and sharpness poor for the X-ray imaging, then doctor difficult to diagnose the problem. So X-ray radiation affects the photographic plate. Okay, so we use a photographic plate to get the imaging. So it's actually a shadow image. It's a shadow image. Okay, the image on the photographic plate is a shadow image. Picture inside the body. You go for X-ray before, when you stand, let's say you want to take the X-ray, they put something at the back, the photographic film at the back. Okay, so it's a shadow image. Okay. So shadow image pictures of the inside of the body as is diagnosing. So this is the picture. So the dark means the dark and the bright. The dark, bright, where the X-ray has been hit the photographic plate with greater intensity. The dark or the white? The dark. The X-ray hits with the greater intensity. Okay. The bone. X-ray when pass through the bone, X-ray will be absorbed by the bone. Bone is a very good absorber of X-ray. X-ray has been absorbed by the bone. Then after that, only little intensity passes after the bone. So when you hit the photographic plate, you can't change the color of the photographic plate that much. So it's just a little white. The dark means the X-ray has been hit with greater intensity. That means the dark means your soft tissues. Okay, soft tissues, when the X-ray pass, the soft tissue cannot absorb lots of X-ray. Majority of X-rays still hit the photographic plate. Okay, dark. Okay, so yeah, this gives a very good contrast. So if a picture is required to bones, this is relatively simple since the absorption of the X-ray photons is considerably greater than the absorption of surrounding muscle and tissue. Bone is very easy. No need to inject any contrast medium into your body. If they want to check blood vessels by using X-ray, then blood vessels not very clear. Soft tissue blood vessel won't give a very good contrast. So what you have to do? You have to inject with the dye. Okay, the dye which can give a good contrast between the blood vessels and the soft tissues. Okay, dye is a big problem. Can give you allergic to your body. Some of you, not everyone. Okay, yeah. So That's why I say if a picture is required bones, this is relatively simple since the absorption of the bone X-ray photons is considerably greater. So you have a good contrast without the dye. Okay, without the dye. Okay, X-ray pictures of other parts of the body may obtain if there is a sufficient difference between the absorption property of the organ under review and surrounding tissues. So to check your kidney, liver, I don't think so. X-ray is good. Kidney, liver, kidney, all they go for ultrasound. Okay, ultrasound, and they inject dye maybe for blood vessels dye. Other than that, for kidney, all now I think best is MRI. MRI for everything. Okay, the hydrogen atom can give a very good imaging. So quality of the X-ray, quality, how quality it is. It depends to how good is the sharpness and how good is the contrast. A picture with high sharpness and contrast lead to the better quality of imaging. So in exam, they'll ask what is meant by sharpness and contrast. How sharp an image is. Sharp is concerned with the how ease with which the edges of structure can be determined. How easy for you to determine the edges of the structure. Sharp. I think maybe sometimes your camera or your setting, okay, you can adjust until the aging between the two edges must be very sharp. Clearly you can define. Okay, like your head and the background. The head edge and the background is like clearly defined. Okay, very sharp. Okay, so sharp means how ease with which the edges of the structure can be determined. How easily. Okay, you need to strain. You don't need to strain your eye to check the edges. Okay, so that is sharpness. A sharp image implies that the edges of organ are clearly defined. Okay, clearly defined. And second, contrast. Contrast is a difference in the degree of blackening. A difference in the degree of blackening. How blackened is one region to another region. The difference in blackening is contrast. They both are same black, same level of blackness. So what you can't differentiate the two medium. So contrast means it's the difference in the degree of blackening. Okay. Sharpness, good contrast. Okay, so how do we achieve this for X-ray? How to achieve a sharp image for X-ray? What we do to get a sharp image? What do we do to have a good contrast? Okay, that's the idea we're going to discuss. Okay, first, about sharp. How to get a sharp image? The sharp image, they found that it depends on the size of anode you use. The size of anode. When the electrons strike the anode, there is a small region. If the electrons strike a smaller anode and a longer anode, the shorter anode, it seems to give a smaller partial shadow. The big anode tend to give a big partial shadow. Partial shadow means double image, two images. Okay, your head is there, but at the same time another head like appearing at the side, double image. So poor sharpness. So how do you improve sharpness? So from this image you can tell. Use a shorter anode. Use a shorter anode. More shorter it is, more sharper the image. Okay. So X-ray tube designed to generate a beam of X-ray with a minimum width. Factor in the design X-ray apparatus that may affect the sharpness include the size of the anode. Shorter the size of the anode, smaller the partial shadow, more sharper the image. Okay. Okay. Passes after leaving the tube. Okay, the size of the aperture. This is the aperture size. The size of the anode can be shorter by using the aperture or the size of the anode. Okay, next the main one is the lead grid. Use a lead grid. Okay, this lead grid. Lead grid. Okay, what is lead grid? I think when you go for an image, when they put the film at the back, they carry it's in a box. So the front is actually a lead grid. It's a lead grid. Why lead grid is needed? You see, if you don't have this lead grid, the X-ray when passes through tend to diffract because the wave, EM wave. When come to the edge, the X-rays tend to diffract up, down, can diffract down. So what happened? Let's say you don't have lead grid. Some X-ray after passes this bone edge, it might diffract to the center. Let's say it diffract. Let's say diffract to the center. So when the doctor see the image, what you'll see at the center will be a dark region. Will be a dark region. So you see a bone, like for example. So this bone, you see the bone, you might see a dark region here, same darkness as this. Yeah. So what the doctor going to think? There is a hole inside the bone. Okay. So if there is a dark region, yeah. Actually, because of what? Because of X-ray has been diffracted. Okay. X-ray diffracted, give a false image. Okay. False image. So we need to help the doctor. So what they do? They put a lead grid after the X-ray passes through. So what the lead grid does, when the X-ray diffracted, the lead grid will absorb that X-ray. The X-ray cannot pass to the film. It will be blocked by the lead grid. The one parallel only will allow to pass through the lead grid. You see, the lead grid is like parallel for a greater distance. Any X-rays parallel to the lead grid will pass through the lead grid and reach the film to produce the image. So any diffracted X-ray will be blocked. Okay, the X-ray which is going straight will be allowed. So there is no diffract and make a hole at the center. False image now for the doctor. So yeah, so this to create a sharper image again, sharp image, so that to prevent from diffraction, we use a lead grid. Okay. Yes, this is how we make the image sharper. Lead grid and use smaller anode. Okay. It's all done by the technicians. Okay. Nowadays, doctor, I don't think so. Nowadays, even I went for the specialist. I don't know whether, I think you don't have time or don't. So when you see the X-ray, because X-ray now is what is a digital one. So after you take the scan, straight away they send to the computer to the doctor. So when you go and see the doctor, you open up the file, see the image. So when you see my image, my neck image, so I don't know, you can't read the image. Okay, you see the image, you say, oh, your structure is. Let me see the record. You go and read the what you call record by the radiologist, then only get to know what is happening. So nowadays, I think the doctor even not really need to know how the images looks like roughly. The radiologist, I think, give the report what happening inside. Okay, the old doctors get to understand what is going on. Okay, when they see the X-rays, but now the new doctors they rely on the radiologist. Okay, to give the details. Okay, next is the contrast. Okay, how to have a good contrast? The blackening, the kidney and maybe the soft tissues is the same contrast. Okay, you can't differentiate with the kidney and the soft tissue. So what they have to do? They have to inject with the blood vessel also. Blood vessel is a soft tissue, not much of a contrast. So they inject with the contrast medium. Barium sulfate is used as a contrast medium. Okay, barium sulfate. I think those who are taking chemistry, maybe you understand better barium sulfate. You learn. I think you learn medical also in your chemistry application, right? How many of you taking chemistry here? Okay, do you doing application for medical? I haven't studied. Haven't yet. I think you'll be learning medical MRI. I don't in a chemistry field. Okay. So ask your chemistry teacher about barium sulfate. Okay, barium sulfate is used as a contrast medium. Okay. 1 year they asked, give one example of contrast medium to be used. So barium sulfate. I was shocked to see that question. It's a fact to remember now. Okay. So outline blood vessels and a contrast medium absorb strongly the X-ray radiation would be injected into the bloodstream. So the contrast of the image produces a photographic film is affected by, these are the 3 factors you can increase the contrast, not only injecting with the dye. You can increase the contrast by increasing the exposure time. Okay, you stand there for a long period of time. Let the X-ray pass through you for not 1 second, but few seconds. Let the X-ray pass through for a much more longer time, so that the region where it's dark become even darker, so create a better contrast. Okay, but it's dangerous, not advisable. Exposure time. Okay, exposure time can increase contrast, but not advisable. Second, X-ray penetration. Okay, yes, X-ray penetration. How penetrative is the X-ray? With the X-ray you send in with a high voltage, more penetrative, so more darker region you can produce. Less penetrative X-ray, the image will become less contrast. Okay, less blackening. So it depends on the X-ray penetration. Again, if the doctor want a big contrast, increase the X-ray penetration by increasing the voltage. Also, I think not a good idea. Dangerous. Okay, penetrative. Third, the scattering of the X-ray beam or the affect the contrast. So another one easy way to increase the contrast is the fluorescent material. Use a fluorescent material. The doctor used the fluorescent material. And you get the film last time, hard copy, put it on the light. So it's actually a fluorescent screen. Can fluorescent light will pass through the X-ray, so give a better contrast. Okay, I think that's the best fluorescent material. Okay, so this is about contrast and sharpness. In exam, they'll ask, how do you improve contrast? How do you improve sharpness? What is meant by sharpness? What is meant by contrast? Okay, how do you improve sharpness? Shorter anode and what else? The lead grid is to be used. How do you improve contrast? Contrast medium and fluorescent material. Exposure time, but not advisable. Top is contrast medium and fluorescent material. Okay, so far calculation for X-ray only one, how to find the short wavelength. Okay, now more calculation about X-ray, not that difficult, but go to the next one. So now we talk about something called attenuation of X-ray, last part of X-ray. Okay, attenuation of X-ray. What is meant by attenuation? Reduction in the power of the signal. A reduction in the power is called attenuation. Your phone signal, when you go further, the signal drops, but in a technical term, they say the signal has been attenuated. Attenuated means reduction in the power. Okay, so X-ray attenuation, reduction in the intensity of X-ray. Attenuation refers to the reduction of intensity. The intensity is power over area. Okay. So when the X-ray reduces as it travel into the medium, when it travel into a medium like a flash, let's say it passed through 5 centimeter of soft tissue, you got X-ray of intensity, and the thickness of the soft tissue, let's say now is 10 centimeter or 15 centimeter. The X-ray comes out, become even more attenuated, more has been absorbed. Okay, so how much will come out? Calculation. They say it works based on this formula. I equals to I naught E negative mu X. Okay. So what is I? I is the intensity. So let's say this is your tissue. This is your tissue. When the X-ray goes in, this is your I naught. After it passes the body, when it comes out, this is your I. The intensity still remain. This X is the thickness of the tissue. How thick it is. Okay. So more thicker the tissue, more smaller the eye. The eye will be smaller. The eye and I now related exponentially. Exponential drop. Okay. And this mu called linear absorption coefficient. It's called linear absorption coefficient. Linear absorption coefficient is depend to the type of medium. Soft tissue, the linear absorption coefficient is small. For a bone, the linear absorption coefficient is big. If mu is big, that means the doctor must understand that majority of the X-ray will be absorbed by that medium. Okay, when the mu is big. When mu get bigger, according to mathematically, the eye will be even smaller. The unit for mu is per millimeter, per centimeter, per meter. Okay, the trap here is when mu is per millimeter, your X must be in millimeter. and mu is in centimeter, x also must be in centimeter. Trap. Okay. So yeah, this is the graph. The original, this is your I. This is the thickness. Okay. So I is what? E negative mu x I naught. Sorry, I naught. So how the x versus I graph looks like. So it's dropped exponentially. Okay. Every half thickness, you know, like half life, half thickness, the intensity from 100 drop to 50, drop by half. Okay. 50 becomes 25 is another half thickness. So what is meant by half value thickness? Like your half life is the thickness of the medium required for the transmitted intensity to become half of its initial value. Okay, it's half thickness. Like last time your half life, what is your half life defined as? Half life, the time taken for the radiation to drop to half of its original value, right? Same thing. Yeah, half thickness. Half thickness. So yeah. So this is the formula you have to remember. Okay. So if you place this I as I naught over 2, okay, and x as half thickness, you will end up getting this formula. Okay, this formula. So this formula is half thickness times mu is ln 2. I think you can survive without this formula. This formula itself will do. Okay. Okay. So we're done with that X-ray calculation. That's the hardness, the what do you call the attenuation part of X-ray. So one question. A linear absorption coefficient of copper is this much. Copper as a linear absorption is 0.693 per millimeter. Calculate the thickness of copper required to reduce the intensity by 50%. So I will be how much? I over I naught will be 50%, should be 0.5. I over I naught will be 0.5, right? So 0.5 must be equals to exponent substitute. The mu is 0.693. Already have negative. This also, yeah, negative. Negative should have negative. So rearrange, you get the half thickness. Okay, B. The fraction of the incident intensity of a parallel beam that is transmitted through a copper plate of thickness 1.2. What the B question wants? They're asking what is I and the X is 1.2 cm. So you use this formula again. This is the only one formula. So I over I naught. They want fraction. They want fraction of the incident intensity. That means looking for I over I naught fraction. So I over I naught equals to, yeah. So 12. Why you put here 12? Because this is the trap. This is in per millimeter. So the X also must be in millimeter. So 1.2 centimeter, you change to millimeter. This the common mistake done by the student. Lots of questions to be done in paper 4. And come to X-ray. X-ray is going to be the 10 or 11 question. You already done with the 10 questions. So exhausted. So when you come to the X-ray, students tend to make a mistake here. Make sure the unit is the same. Mu per millimeter, the X must be in millimeter. Okay. Yeah, so that's all about X-ray. Okay. So what did you learn today? What about X-ray? Okay. Anything else? The formula. So how many formula you learn in X-ray? 3. what are the three formula? First, EV equals to AC over lambda to get the shorter wavelength. Then the intensity formula, I equals to I naught E negative mu X. Only two formula for X-ray. EV equals to HC over lambda, and the I equals to I naught. These two formulas. So today you learn about imaging. You learn about imaging. Okay, how sharpness to be improved, how contrast to be improved. Okay, and how attenuation happens. Okay, two ways sharpness to be improved. How? Use a smaller anode, then as a lead grid, have a lead grid to have a sharp image. How to improve contrast? Dye. Okay, use a contrast medium. Second, use a fluorescent screen to be used for the contrast. Okay. So I don't want to do this today. So next is CT scan. Okay, CT scan we'll do that tomorrow. Tomorrow we have practical. Maybe the last half an hour I spend time with CT scan. Okay. CT scan. So CT scan also looks the same way, same machine. Okay, tomorrow we look at it. Okay, so I stop it.